Okay, so we're going to have a look at the introductory video here on moles calculations. So we're moving into the GCSE Unit 2, where we're moving away from solids, although this still will have lots of calculation involving solid, but we're moving now into solutions of those moles calculations. So we're dealing with basically substances which are dissolved in water, and what sort of quantities are they dissolved in water, and what sort of quantities do they react with each other. So we'll just talk very quickly through the formulas that you need to know and that you need to be able to work between if you're going to have success in this area. So first of all, we have the formula from last year, okay, from Unit 2 Year 11, which is mass in grams is equal to moles multiplied by the RFM. Okay, so that should be very straightforward. You should have done lots of calculations with that before. We'll still use that now. You then have a new one, which is moles equals this time concentration, in which the units are moles per decimeter cubed. Decimeter cubed, for those who aren't quite sure, is 1,000 cubic centimeters. Okay, which is essentially the same as a litre. As 1 litre. Okay, so moles are concentration equals moles divided by volume. Okay. And then we have another unit of concentration, which is grams, basically the mass of something dissolved in it, again a decimeter cubed, okay, and that is equal to concentration in moles per decimeter cubed multiplied by the RFM. So you need to be able to work quite easily between 1, 2, 3, all three of these. Okay, so you can see there's a link between them. Okay, so that one is linked via that. This one we can go, okay, in those directions via that. Okay, and we might also have an RFM, which can bring us from there to there. So the skill that you need to have in order to be able to answer these questions is to be able to work between the numbers that the examiner gives you and between these three equations. You need to know them really well. And then of course the second skill you need to have is being able to deal with the stoichiometric ratios, or the reactant coefficients that you get in an equation. In other words, how many moles of one thing reacts with how many moles of another, and how many moles of a product then in turn are actually made. Okay, so a couple other things just on the side there, you see it written down below. Just if you are, very often your questions will come to you, the volumes will come to you in centimeters cubed, and if you notice up here, our volumes for this equation are in decimeters cubed. Okay, so we need to take those centimeters cubed and divide them by 1,000 to turn it into decimeters cubed. Frequently students will forget to do that, and there will get their answer to be well, maybe 1,000 times too big or 1,000 times too small, depending on whether they're calculating out concentration or moles. But that's a really important step, you don't want to forget that. Okay, just here, also moles per decimeter cubed can be represented as capital M. So when you see me or anyone, I suppose, writing capital M, it means the same thing. Also you might see sometimes moles per decimeter cubed written as this. Probably more likely to see that at A level, but nonetheless it may see it at GCSE. So just be conscious of the fact that it means exactly, that all three of those terms that we have there mean exactly the same. And just a reminder that a decimeter cubed is equivalent to 1,000 cubic centimeters, which is equivalent to a litre. So those are the various different units of volume you might get your question in. So you might want to maybe take a picture of that screen or write those down, because we're going to do some worked examples, and you will of course need those. So I'm going to clear them off the board now. I remember. Okay, right, so we'll just get stuck into a few worked examples. I've got a worksheet here from class which I'll zoom in on, and then I'll do a few of them, and what I'll do is if I zoom in on them like that, then at least you guys can pause the video and you'll have those questions available to you. Okay, so I'm gonna do just probably a couple from task 3 and a couple from task 4, just to kind of show you how to do them, and then you can crack on with them yourself and hopefully have some success. These are just sort of really using those equations to work out something straight from them, and then the more complicated tasks down below will be taking the equations and working out moles of one thing to get moles or concentration or volume of something else. Okay, so this is really in task 5, where we'll be sort of applying that information that we've done. Right, so I'll do a couple of this. I'll do the first one. I'll try and keep that sort of on the screen so you can kind of see it, and I'll work over to the side of it there. Just do this. So if I do the first one asks us here, we've got to calculate the concentration here in both moles per decimeter cubed, and it says it's missing there, but it's grams per decimeter cubed both. So we'll do the first one. Okay, and the first one's nice and easy because in the first one we've very kindly given you the formula. Okay, so you don't have to work out the formula yourself, but if you look in the others here, you've got to work out the formula. So again, I'll do one of those, but if you don't know how to work out formula, you're going to have to go away and revise that and make sure you are capable of working out formulas, because if you can't work out formulas, you're not going to be able to do these. Right, okay, so the first one is we've got 20 grams of calcium carbonate. Okay, examiner has asked us to get that into both moles per decimeter cubed and in grams per decimeter cubed. So if you just remind yourself of the formulas, okay, we can first of all we can get our moles of this, okay, by taking mass divided by the RFM. The RFM of, sorry, scale that a bit, sorry. Okay, so we've got to get moles of this, so we take the mass, okay, and the RFM. So remember, moles equals mass, that's M over RFM, okay, as we had on the previous board, and that equals, of course, 0.2. So in this, we've got 0.2 moles of calcium carbonate. Now that is dissolved in 100 cubic centimeters, okay. Hopefully you can see that. Okay, so it's dissolved in 100 cubic centimeters, so we've got to work out the concentration. So remember, N, number of moles, N's number of moles, when I write shorthand, equals concentration, which is in moles per decimeter cubed, multiplied by volume, okay, which is in decimeters cubed. Now, this is in 100 cubic centimeters, and remember that divided by 1,000 is 0.1 decimeters cubed. So now we've got everything that we need. We've got the volume in decimeters cubed for here. We've got the moles here, which is 0.2. So all we've got to do is 0.2 over 0.1 is of course equal to 2. Our units are moles per decimeter cubed. So the concentration of 20 grams of calcium carbonate dissolved in 100 cubic centimeters of water is 2 moles per decimeter cubed. Now the examiner has also asked us to get it in grams per decimeter cubed. So remember from earlier, our concentration in grams per decimeter cubed is equal to our concentration in moles per decimeter cubed, okay, multiplied by the RFM. So we've currently got it in moles per decimeter cubed here. The RFM we actually calculated out earlier, so it was 1 calcium, 1 carbon and 3 oxygens adds up to 100. So basically all we're doing here is moles per decimeter cubed, which is 2, RFM is 100, equals, this is equivalent to 200 grams per dm cubed. Okay, so simple as that. That was a nice easy one. We were given the formula and none of the volumes or the masses were particularly challenging. Right. So we'll take another one here and see how we get on with that. So in this one here we'll go for a D here, so I'll just hold it up to the thing so you can see it. So D asks us for we've got 0.0375 grams. In fact, we're going to go to do 2.79 kilograms of iron 2 dichromate in 5,000 cubic centimeters of water. So first thing we need is to work out the formula of iron 2 dichromate. So iron is Fe, it's iron 2, so it has a valency of 2. Dichromate ion, which you just have to know, Cr2O7, again valency of 2. So it's, if we do our swap and drop, it's 2 and 2, but we just keep that as a 1-to-1 ratio. Okay, so iron dichromate is FeCr2O7. Okay, so the first thing I'll look at that is to say, well, we should have quite a high RFM when we go to calculate the RFM. So just sort of a mental check that when you do so, you have a relatively high number. If you have a low number, you've probably made a mistake. Okay, right, so we have 2.79 kilograms. Now the first thing that I need to do to that is turn that into grams in order to use it in my moles equals mass divided by RFM. Okay, so my moles equals mass, which is that, so divided by the RFM. Okay, so we need to get the RFM of this. Okay, so the RFM is 56 plus our 104, which are 2 chromiums. Okay, and then we've got our 7 oxygens. Alright, so that all adds up to 272. Okay, so therefore 2790 divided by that gives us 10.25 moles of that. Okay, so if we take that and sub it into our second equation, which was a number of moles equals concentration multiplied by volume. Okay, remember our concentration, this one is our moles per decimeter cubed, and our volume is again in our decimeters cubed. Okay, so if we look at this question, it's in 5,000 cubic centimeters. So 5,000 cubic centimeters turned into decimeter cubed is 5. Okay, we have our moles up here at 10.25. So if we take our 10.25, divide that by 5, that gives us 2.05, and our units are moles per dm cubed. Then we've been asked to convert that from moles per dm cubed into grams per dm cubed. Okay, and our grams per dm cubed is, if we can remember, just go grams per dm cubed is equal to moles per dm cubed, which we had in the previous question, multiplied by the RFM, and the RFM of this we've already worked out earlier is 272. So we're taking that and multiplying it by 272, gives me 558 grams per decimeter cubed. Okay, so that's how you do a couple of those. Pretty straightforward, I hope. So there's a few more there that you can do. If I just zoom in on them there quickly, and then maybe you can pause your video and have a go at a few of them. Okay, and then what I'm going to do is I'm going to move on into task 4 here, which is similar sort of idea. We're still manipulating the same formula, but obviously got different questions. So we'll zoom back out again. So this time we'll do a couple of these as well. Let me see which ones. Right. Okay. So we'll do we'll do letter F here. Okay. So in F we've got, I'll just write it up here. I've got 5 litres of 0.56 moles per dm cubed, and it's sodium dichromate. And again, you need to be good at writing your formulas here in order to get the sodium dichromate formula right. Sodium is 1, dichromate is 2. So we do our swap and drop. So that's the formula of sodium dichromate. Okay, so we'll just very quickly work out the RFM of that. Okay. So the RFM of that relatively high, as we would expect, 262. Okay, so the question here asks us to work out two things. We've been asked to work out moles, and we've been asked to work out mass. Okay, so again we just remind ourselves very quickly of the formulas that we need to be aware of. So it is mass, moles times RFM, and it is moles, concentration in moles per decimeter cubed, that's concentration, times volume, which is in dm cubed, and we've also then got, these are not equals, and we've then got concentration, which is in grams per dm cubed, divided by equals, concentration in moles per dm cubed multiplied by the RFM. Okay, so we've got to get moles, alright? So we've got volume, we've got concentration, so we can easily get moles. Okay, it is concentration times volume gives me moles. Now my volume here is in litres, which is fine. A decimeter cubed, just remember back to the sort of first few minutes of the video is the same as a litre, so therefore my answer is going to be volume is 5, concentration is 0.56 moles per dm cube. So my moles is 5 times 0.56 gives me 2.8 moles in this instance. So the examiner also asks me then to get the mass. So I've got moles, I'm after mass here. So moles times RFM is the mass. We've already got the RFM up here. Okay, if we didn't, we would just quickly calculate it out. Okay, and that gives me 733.6 grams. So that's what mass of sodium carbonate, or sorry, sodium dichromate I would need in order to make a solution of 5 litres of 0.56 moles per decimeter cubed concentration. Right, I'll do one more. Okay, and then it would be up to you guys. Right, so if I have a look at, we'll take a look at G here. Okay, so I'll just write out G for you because it's probably too small for you to see. So we've got 0.345 cubic centimeters. Okay, and 7.8 moles per decimeter cubed of sulfuric acid, and again it's a formula. That's a formula you should know off the top of your head, really. Okay, so again we've got to get two things. We've got to get concentration in moles per decimeter cubed, and we've also got to get the mass of that solid that would be needed. So we'll get rid of this stuff from our last question up here. Okay, so molar mass of sulfuric acid, the RFM of sulfuric acid is 98. Okay, that's a sort of useful fact that you pick up as you teach a bit of chemistry. It's actually quite a good RFM to have embedded in your head, guys. See if you're working right in an exam, it does come up rather frequently. Okay, so we go back to our equation and we remember that concentration in moles per decimeter cubed is a, sorry, that's not what I'm after at all. It's, sorry, excuse me, well, the first thing we're after is number of moles. Okay, moles equals concentration in moles per decimeter cubed times the volume. So we've got our volume here at 0.345 centimeters cubed. So we've got to take that 0.345 and turn it into decimeters cubed, which will be take that and divide it by 1,000. Okay, so that gives us a value of 0. And we've now got 3 zeros and a 3, 4, 5. Okay, so a very small number, but nonetheless it has to be in decimeters cubed. And we're taking our volume and we're multiplying it by our concentration, and that's 7.8 from the question. Okay, and that gives us an answer of 0.00269, and that is of course moles. The next thing we're into is mass. So we've now got moles. We can take our moles from there, pop them into this equation and multiply them by the RFM, which is of course 98. Okay, so 0.00269 times 98 gives me a mass of 0.264 grams, and we'd expect a very low mass there. It's always good to sort of double guess or estimate your answer. Okay, so I'll just put those back on there, guys. There's a few more of them that you can, I'll just zoom in on that you can do. Hopefully you've got the idea now as to what you need to do and how you would go through those. The rest of them are all pretty much the same as what I've just done. Some of them I've written CC here, by the way, that stands for cubic centimeters. Some of them I've just sort of used different units, so I've used litres here, but that's the same as decimeters cubed. I've used decimeters cubed here, I've used litres, I've used cubic centimeters, but really those are things which we wouldn't expect to throw you at this level. Okay. Okay, likewise up here we've got some in grams and some in kilograms. Alright, but again, units that shouldn't really throw you. We've got litres and cubic centimetres both on this side, but you should be well able to deal with those. Okay, so good luck with those. If you need any help on the answers, I've got the answers in class and you can check those. Okay, so there's the answers. You can check them off. I think on the second one I asked for both moles and the mass, but I mean if you get the mass right, you're clearly getting the moles right. Okay, so don't worry about the fact that those are missing. It should be pretty much, as I say, if you get one right, you get the other right. Okay, so hopefully that's all grand. That, by the way, there is a point, so it's like 2.05 moles per decimeter cubed. Alright, hopefully that helps, guys, and any queries please let me know.